Hello again all. This is the Pencrest High School AP Physics 1 video series. Video 1F. This is graphical construction. Now the last part of our graphical kinematics consists of using a velocity versus time graph to construct both position and acceleration versus time graphs for the same motion. This skill is going to involve both qualitative and quantitative analysis. Some of the steps we've done individually, but not in this particular context. So we're going to look at this velocity versus time graph. We're going to use it to produce a position versus time graph and an acceleration versus time graph. You should have a nice printed version on which to construct your graphs as we go through this. So when we're going to generate a position versus time graph given velocity versus time, we're going to need one additional piece of information besides the graph itself. We need to be provided with the initial position of the object at t equals 0. For this particular problem, we're going to use x sub 0 or x naught is 250 meters. This is going to allow us to anchor our curve. So we'll get to the steps here. Number one, we're going to plot the initial position on the position versus time graph at t equals 0. Two, we're going to determine the temporal boundaries of the first interval. In other words, when it starts and when it finishes. The easiest way to tell is look at when the motion changes. Number three, we're going to calculate the area under the curve for this interval, finding the displacement. Again, we've done that already. And four, we're going to add this displacement that we found in the first interval to the initial position. Again, displacement is the change in position. So this is going to let us know what the final position is at the end of the interval. And we'll plan to keep a running total. Step 5, plot the final position at the time indicated by the end of the first interval. 6, we're going to connect the initial and final positions with the appropriate curve based on the type of motion. Again, this is involving qualitative analysis. You should be able to determine the type of motion based on the velocity versus time graph in the first interval. Step 7, we're going to continue on to the second interval of motion, repeat steps 2 and 3, figure out the boundaries and find the displacement and so on. We're going to add the displacement found in the second interval to the final position from the first interval. Again, the displacement in the second interval tells us how far it moves during that interval. This is why we need to keep a running total of the positions. Number 9, we're going to plot the final position at the end of the second interval. Connect the initial and final positions for the second interval with the appropriate curve, again based on the type of motion. And then step 11, repeat for all successive intervals until we're done with the graph. So we will apply these steps to the velocity versus time graph that you have. First, we'll plot the initial position. We'll take a look at the graph and determine when the first interval ends. We can see that it changes at 8 seconds. So the first interval goes from 0 to 8 seconds. We're going to find the displacement. Here's my calculation. 1/2 base times height. Again, this area is below the time axis. It's going to indicate a negative displacement in the first interval of negative 180 meters. We then take the initial position, x naught, we add the displacement, negative 180 meters, and we see that at the end of the first interval, the object is located at 70 meters to the right of the origin. Now, on your blank position versus time graph, we plot the initial and final positions at 0 and 8 seconds. Okay, there they are. And then we need to determine, again using qualitative analysis, what kind of motion the object has in the first interval. If if you look at the velocity versus time graph, you should come to the conclusion right away that motion is minus plus a, moving left and speeding up. We know what that looks like. In a position versus time graph, it's curving down and to the right, again with a negative curvature. Okay, now you're going to continue to apply the steps for each of the following intervals until the 60 seconds is up. If you're going to do this on your own, now's a good time to pause the video. Remember to keep a running total of where the object is at the end of each interval, so you know where to start the next one. When you're complete, when you're finished, the graph should look like this. Maybe not quite as smooth in terms of the transitions, but you get the idea. Now, when we generate an acceleration versus time, given velocity versus time, this is much easier. Step one, we're going to calculate the slope in the first interval. We've done this already. This is, of course, is the acceleration in the first interval. We're then going to plot, step two, plot a horizontal straight line at this value on the acceleration versus time graph for the duration of the first interval. Again, we've made an assumption that for a given type of motion, the acceleration of the object is going to be constant. So we're going to plot it as a constant for the duration of the interval. Then we're going to calculate the slope in the second interval, plot a horizontal straight line at this value for the duration of the second interval, and then connect the end of the first interval to the beginning of the second interval with a straight vertical line. We're going to assume that the acceleration changes instantaneously, and then we continue for each successive interval. So going back to our velocity versus time graph, take a look at the first interval, again 0 to 8 seconds. We're going to calculate the slope. We've done this already. So delta V over delta T. Here's my final velocity. Here's my initial velocity, final time, initial time. We end up with negative 5.6 meters per second squared. We're going to go to the acceleration versus time graph, plot a horizontal straight line, you see it here in blue, at this value, negative 5.6, for the entire first interval, which ends at 8 seconds. Now the second interval on the velocity versus time graph, finding the acceleration should be easy. In the second interval, the motion is minus CV. Constant velocity, of course, implies no acceleration. So the velocity versus time graph is a horizontal line, has no slope. The acceleration in the second interval is 0. We plot a horizontal straight line there. Here it is. And then we connect the ends with a vertical line like this. All right. Continue calculating the slope for each of the remaining intervals. Again, if you're going to do this on your own, now's a good time to pause the video. When you're done, your completed acceleration versus time graph should look something like this. Sometimes called a step graph or step function. All right, so that will actually conclude our graphical analysis. You can see construction of graphs involves a number of the skills, both qualitative and quantitative, that we've already looked at. You can expect at some point, quiz or exam, to be given a velocity versus time graph. You'll be asked to produce both position versus time and acceleration versus time graphs. Of course, when you do so, you will not have the steps listed in front of you, so you'll need to be able to conduct or construct the graphs from memory. All right, that'll do it. Until next time, I'll see you soon.